I will be talking about metadata standards and interoperability. First, let us have a look at what exactly is metadata. A simple definition is data about data. Actually, when it comes to the exact meaning, metaphysics, for example, if you take, that is beyond physics. But here metadata is used in a different sense, that is data about data. If you have a document, the data about the document, or if you have an object, for example, some chalk piece. So, information about chalk piece is metadata. So, basically it is structured information about the data, because we know in database management systems and in computers in general can handle structured information fairly well, whereas unstructured information machines find it difficult to process. Only human beings can process unstructured data, but metadata is a structured data. That means normally it is stored in a kind of a database management system for further search and retrieval. So, the metadata, its use, for example, it is meant for communities that design, create, describe and preserve use information sources. So, any information source in our particular context, a digital object, metadata is used for its design, creation and basically the purpose is to describe. So, a broader definition of metadata is the sum total of what one can say about any information object at any level of aggregation. So, if normally when it comes to metadata description, we talk about granularity, which is a technical term. More granular means you are giving a very detailed information. Less granular means you are giving broadly a definition. In that sense, Mark 21 or Mark XML is highly granular, whereas Dublin core is less granular. For example, if you take date, okay, just if we mention date, it is less granular. But if we talk about date issued, date uploaded or date accessed, date created, like that, if we keep on refining the date, we say that the date element is much more granular. Okay. So, let us go into some of the features of information objects, then we will connect it to metadata. So, the content of any information object, we talk about what it deals with. The context is who, why, where and how aspects of the object, that is who created, what was created, why it was created, where it is located. All these aspects are the context about the object, which normally we should be able to include in the metadata. Then structure. So, formal set of associations within and among information objects. Sometimes we talk about relation between the elements or relation of this metadata or the object it represents to another metadata where it represents another object. So, functions of metadata, basically it is a powerful resource discovery tool. In fact, I dare say that the web search engines really do not retrieve refined information as in the case of bibliographic data like in data systems like CDS ISIS in good old days or Koha for that matter, where we can have really powerful refined searches. Just imagine that can you use a web search engine to find out what are the books by Ranganathan. In fact, it only gives wherever Ranganathan appears, it retrieves. But whereas in Koha, I can say if the word Ranganathan appears in the author field, retrieve it. Otherwise, I don't want that information. That means you get less noise. That means you have more precision in the data that is retrieved with metadata. if metadata is absent, you cannot really have refined searches or even like range searches. Books published by Ranganathan between 1930 and 1950. This kind of searches are not possible on web search engines, whereas they are very much possible in Koha or DSpace where metadata is being used. So, that way metadata is a very powerful resource discovery tool. Then it also is helpful in organizing e-resources, allows grouping of resources by subject, author and other things. So, when we create a browsing facility by title or author or subject or by date or by research guide, all this is possible to provide a kind of a browsing facility in DSpace like repositories. That is because of the metadata. Then it facilitates interoperability. So, when we want to exchange metadata, that is information about objects, after all information objects can appear in various repositories, the same object may appear in various repositories, then once it is created, okay, others can share the metadata. I mean, that is the very purpose of the creation of MARC21 or CCF or Unimark, all these metadata schema. Of course, good old days they were called bibliographic data exchange schema. They are all meant for resource sharing of shared cataloging, okay, which really helped in shared cataloging. Then digital identification. So, uniquely metadata uniquely identifies a resource on the net, because one of the essential components of metadata is the digital object identifier or a CNRI handle. And archiving and preservation. This is definitely one of the purposes of metadata, which provides information on versioning of very documents, the format standards. Whenever a document format is migrated from one version to another version, for example, something like Word 2003 to 2010 or something like that, and we have to record that information that this is migrated from earlier format to the another format. So, let us categorize the metadata elements, because metadata, if it has to have various functions, naturally the metadata elements increase. Then if we try to group them into various categories, we may find there are administrative metadata, descriptive metadata, preservation metadata, technical metadata and use metadata. So, let us go into each one of them, what exactly they include. So, administrative metadata is used for managing and administrating a information resource. So, the examples of administrative metadata are the date of creation and modification, then who created the object and or whether the object was already modified, or who owns the rights or copyrights related to a digital document, who are the audience, that means whether it is meant for for example, school children or researchers or general public or something like that. Then location information, where exactly the metadata is available, okay, whether it is on a website or in a physical library. So, when we talk about metadata, it does not mean we are talking about metadata of electronic items only. After all, on every entity we can create metadata. In future, we believe that though thus we have been dealing with metadata about digital documents, in future on every entity, for example, about a toothbrush we may need metadata, or any product in a retail shop we require metadata, or we may require metadata about organizations like for example IGNOU, so or even ISI, when it was established, who is the director, what courses offered, how many students, how many faculty, all this is information about a particular organization, or about individuals also, about an author or about a painter or a musician. We can create metadata, or even events. For example, a particular conference or seminar, we can create metadata. What is the title of the conference? What is the dates of the what are the dates of the conference, and how many participated, who are the resource persons. So like that, about events, processes, we all require metadata. In fact, that is the goal of the so-called semantic web. Anyhow, coming back to the one, so we need versioning and about of various digital objects. This is all administrative metadata. Then descriptive metadata, we are more familiar with descriptive metadata because it does look much like our cataloging data. Metadata used for describing and identifying information resources, especially used for indexing like proximity search, fielded search and other search techniques, and resource discovery, identification of a digital resource. Examples are Dublin Core, MARC and MARTS. Or even we can include even annotations by users or hyperlinks to other metadata resources. Then preservation metadata. Okay. There is an exclusive metadata schema called a framework for metadata called premise, but here just I would like to mention that preservation metadata can also be included in metadata. Metadata related to preservation management and information resources. This is information about the physical condition of the resource. Okay. Then information regarding migration of older formats to newer formats. Sometimes we may say that it is recorded on a digital tape or digital audio tape, DAT drives or optical drives or even external hard disks. This is all about preservation metadata. Then there is something called technical metadata, metadata related to how a system functions and our metadata behaves. That is hardware and software, documentation, digitization information, formats, compression ratios, scaling routines, tracking of information, response times, and authentication and security data, especially encryption of keys and passwords also can be included in the technical metadata. Then lastly, we have use metadata, metadata related to the level and type of use of information, that is use and user tracking, contents of reuse and multi-versioning of information, all these are included in use metadata. So let us go into the metadata standards. Okay. Then we have MARC XML. Okay. The more or less I call it the granddad of the metadata schema because it is the most granular, rather verbose, and only library catalogers can handle this kind of schema. A comprehensive bibliographic description of MARC expressed in XML, and it is based on AACR2 and requires nuances of definitely library cataloging and has more than 1,000 content designators. And as far as I know, CDS Invenio, that is formerly it is called CDS Wire from CERN Labs, uses MARC XML. It can be crosswalked to Dublin Core because as it is has many elements without though it loses some of the data, but it can we can create a complete Dublin Core schema out of it. Dublin Core, the most popular metadata schema on the web. Presently it has about 15 elements and it is version 1.1, and World Wide Web Consortia approved it and it's OAI compliant. In OAI PMH we refer it as OAI DC, widely used in digital repositories. OCLC maintains the DC standard and used as the lowest common denominator vis-a-vis other metadata standards to facilitate use by communities and other trained library and information specialists. There are many metadata schema. In fact, one of my students, when I asked her to collect the list of metadata schema, even about 3-4 years back, she came across about 200 schema. Many of them probably are highly specific, used by very small communities. But again, we do have. That is the reason Dublin Core is considered as the lowest common denominator across many a schema. So there is something like CWA, categories for description of works of art, and CCO, cataloging cultural objects, then object ID, standards for describing art, antiquities, others, then CIMA, computer interchange, museum information. Then FDA, foundation for documents of architecture, so that means it deals with architectural drawings. Then EAD, encoded archival description, then ETD, electronic thesis and dissertations metadata schema. Then GEM, there is a gateway of educational material, then IMS, instructional management systems, LOM, learning object metadata. These of course mostly being used in e-learning objects. How do you describe them using one of these schema? Then ONIX, that is online information exchange, mostly used by the publishers and the publishing industry. Then TI, text encoding initiative, mostly in social sciences it is very popular. Then VRA, that is Core Visual Resources Association Core. Then METS, metadata encoding and transmission standard. Then FGDC, then Federal Geographic Data Committee, eGEMS, e-governance metadata, GILS, Government Information Locator Service. So all these deal with mostly the government information for e-governance purposes. So some of the issues in metadata. The biggest challenge is which metadata format to choose or the schema to choose. Whether to, because Mark XML is too complex and Dublin Core is too simple. And personally, of course, I prefer Dublin Core for its simplicity and functionality. Okay, Mark XML may be too complex, but maybe I think library community would be much more happy to use Mark XML rather than Dublin Core. But in any case, in the context of digital repositories, it is Dublin Core, but again DSpace uses more granular approach or the Dublin Core's sibling called Qualified Dublin Core, which we will discuss in one of these lessons. Then metadata choice is bound to be domain specific. As you have seen, some of the metadata are dealing with government information, some metadata are dealing with antiques and museum pieces, then some metadata are dealing with e-governance, then like that we have so many highly specific metadata schema. Perhaps though Dublin Core is a generic metadata schema, when the different highly domain specific specialized communities, they may opt the metadata schema that are more suitable to them. For example, in case of e-learning objects, you know that there are a few metadata schema dealing with e-learning objects. So is the case governance, e-governance. So in a distributed environment, different metadata formats may pose serious problems of interoperability. So the biggest challenge is how do you share metadata across domains, because if each metadata, if each of those repositories which are highly domain specific, if they opt for metadata schema which is more suitable to them, whether we can have cross domain interoperability of exchanging the data across the domains. That is the biggest challenge when we go for highly specific metadata schema. That is the reason many people believe that Dublin core, because it has the core elements which appear across the many schema, is the lowest common denominator. And probably Dublin core can be adopted for generic purposes, or even if they use a domain specific metadata schema, Dublin core can be used as a data exchange or interoperable schema across the other metadata schema that are prevalent. So, metadata crosswalk, normally this kind of a crosswalk can be achieved using XSLT, okay, XSL transformations. But remember, with my experience in good old days for retro conversion from one mark format to another mark format, that is CCF to Mark 21 or Mark 21 to Unimark, and all this is not without much loss. Okay. So, we cannot really have a complete migration from our data exchange from one format to the another format. Typically, imagine a situation, I wanted to transform Mark 21 into Dublin core. Mark 21 has over 1000 elements or sub elements, Dublin core has only 15 elements. That means I may put all the elements related to that appear in Dublin core, I can put them, but rest of the probably 900 and other elements, I have to just discard them. Okay. So, but again imagine the situation, I am transforming Dublin core to Mark 21. I have only 15 elements, that means only 15 elements or sub elements in Mark 21 are filled, whereas rest of the elements would appear empty. That means you got an incomplete mark record. That is one problem. Okay. Or Mark 2 Dublin core, you lose lot of data. Okay. You have to drop much of the data. So, any transformation either would result in loss of data or incomplete data. This is the situation. Sometimes even more tricky problem comes when assume that in one metadata schema imprint is entered into one element, but in another metadata schema it is divided into publisher data, place of publication. How to tell the machine how to identify this set of words represent the publisher's information, whereas this set of words represent the place of publication, which is very difficult. Okay. So, that is why when we say one-to-one relation between two elements of two different metadata schema exchange is possible, and many to one also is possible because you only merge the elements to get one element, but splitting, that means one to many, is not possible. This is one of the serious problems in retro conversion, which nowadays we call retro conversion as crosswalk. Okay, metadata crosswalk means we are transforming, retro converting one data from one schema to data into another schema. Then how to meaningfully merge metadata about the same information objects from different data providers. That means if I am trying to provide a service, okay, for example, I want to, using OAI PMH protocol, I want to collect metadata from various repositories and provide a single stop search engine to various digital repositories. But if they are following different metadata schema, then the problem arises. That is the reason we believe probably that is perhaps the reason why W3C approved only Dublin core, which is the core elements or lowest common denominator. So, if we collect at least Dublin core related elements from various schema and put it in a search engine of a service provider, perhaps we can manage the service. So, filtering at set level is possible, but not ontology based. So, metadata doesn't, though it has, Dublin core has subject descriptors, only qualified Dublin core has the qualification what kind of subject descriptors are followed, that is whether the vocabulary control device used to identify the descriptors is mesh or another Sears list or some kind of a data. So, machine readable rights management has to be worked out. Of course, much of the publishing industry is worried about the rights metadata, and still there is no generic agreement on how to represent the rights metadata, how to extract metadata from non-OAI compliant repositories. See, in OAI compliant repositories, it throws this metadata in a structured format. For example, if a journal is not supporting OAI, as in the case of OJS, then how to extract metadata from open access journals having no support to OAI. So, in conclusion, metadata is the most powerful discovery tool. Probably in future, if more and more websites have metadata about the content they have, we can have refined searches. If metadata is in place, okay, and we can have refined search facilities which none of the search engines can provide, and metadata is the key search component in DSpace and Koha and such software, so that you can have very powerful searches in retrieving more precise information with least noise. So, metadata is the crux of search and search facilities.